Hey guys, today's lab we're going to determine equilibrium constant. I'm going to work through these examples and that way you can use them to study for a test or take the quiz. So if you've read the chapter so far, you know that the equilibrium constant is equal to the products, the concentration in this case of the products, divided by the concentration of the reactants. We are going to use this equation here to determine our equilibrium constant by varying the concentrations. If you notice, this reaction is a 1-to-1 ratio, which is useful for determining concentrations later. In the lab, we would use absorbance measurements to develop a standard curve. And then we could use that standard curve to calculate the concentration of our reactants and products. But in this lab, because it's online and we can't use our instruments, we're going to use these three equations to just calculate the concentrations. And I'm going to give you made up results as if we had done this in the lab. So following the procedure, we would make up these 4 separate concentrations. Notice that the concentrations of the thiocyanate is what's changing. We're increasing it with each trial. And we're also making a standard solution with 18 milliliters of the iron plus 2 milliliters of the thiocyanate. This one's actually a really good lab, and I'm a little bit sad that we don't actually get to perform this ourselves. So this page is just our calculations, and it lines up with the worksheet for numbers, like step 1, step 2, and step 3. It pretty much walks you through all the calculations. So if you would like to run through those calculations yourself, I will give you these examples, and you can stop here and then do all the calculations and come back and check if you got them right. Or you can just go through these calculations with me. I'm going to do examples of each one. So if we say for trial 1, we got an absorbance of 0.244. Now these are made up, and I will warn you that our Kc values are going to be kind of crazy because I didn't know what numbers to guess and couldn't find an example on the internet. But the math is still the same. And sometimes that's what happens in lab. You get crazy numbers even though you did everything right. So we're just going to go with it. So here's where you would pause if you would want to work these out for yourself. But I'm going to go ahead and do a couple of examples with you. For this box, all they're asking is for the expression. They don't want you to put any numbers in or anything. So if we remember again, Kc is the concentration of our products divided by the concentration of our reactants. So for this equation, in the previous pages, it would be the concentration of iron thiocyanate it's a metal complex, which you get to learn about later. They're very cool. Divided by our reactants. So on the next few pages, I'm going to work these out to fill in this form. So we put our calculations down here. So if you can see right here, they have the steps listed. So I'm going to number them as the steps are numbered. So step 2, trial 1. So we're calculating the concentration of iron that we initially started with. And if you look back to our equation section of this lab, it has step 2 here as using this formula. So they made it easy for us. So we just plug in our numbers. Which for trial 1 would be 5 milliliters divided by 10 milliliters multiplied by 0.0020 molarity, which, if my calculator is correct, now I'm just using a cell phone calculator, so feel free to double check these numbers, should be 0.001, which I'm just going to add to the chart. Now if we go back to the table that tells us how to mix our concentrations, we will see that these were all the same, and so all the trials would be the same for the initial iron concentration. So I'm just going to fill that in here. So for step 3, we're determining the concentration of the thiocyanate. So we're going to start with trial 1. That's how many milliliters we added, divided by the total milliliters of the solution, multiplied by the concentration of our solutions that were given, our standard solutions, our stock solutions. So trial 1 would then equal 2 milliliters, and you can reference back to the table for these, divided by the total 10 milliliters multiplied by 0.0020, which again, if my numbers are right, double check those, comes out to 4 times 10 to the negative 4 molarity. So I'm just going to add that to the table. And I'm going to do trial 2. So trial 2, we added 3 milliliters to a total of 10 milliliters multiplied by the concentration. So these cancel out, and that leaves us with just molarity, which is what we're looking for. And that number should be 0.0006, or 6 times 10 to the negative 4 molarity. I forgot a 0 here. Be sure you include all your zeros. That gets me in trouble a few times. So I've already done the calculations for the other 2 trials, so I'm just going to fill those in now. So now we can go on to determining step 4, which is the concentration of our product. If I can get the right tool. This is our product at equilibrium. So the iron thiocyanate. And this is equal to the absorbance of our trial divided by the absorbance of the standard. That's the number I guessed on, and that's why our Kc is crazy. Multiplied by the concentration. So then trial 1 would equal our absorbance of that trial divided by the absorbance of the standard. Again, multiplied by the concentration. And that comes out to 1.93 times 10 to the negative 4. And we're just going to add that to the table. And then I've already done the other trials. Be sure to double check my math. Now we're going to calculate the concentration of iron at equilibrium. And that's just the initial concentration of our iron minus the concentration of the product because it took that much to use it at equilibrium. And that's where the 1-to-1 ratio comes in handy. Makes it a little easier on this experiment. So for trial 1, our iron at equilibrium concentration is equal to 0.001 minus 0.000193, and that equals 8.07 times 10 to the negative 4 for our iron concentration. So I'm just going to add that to the chart. And I've also done the rest of the calculations. So I'm going to add those to the chart also. Again, double check my numbers. And the calculations for the thiocyanate in step 6 at equilibrium is very similar. So that's our initial concentration minus the concentration of our product, because that's how much it needed to use of our initial concentration. So for trial 1, that would equal 0.0004 minus 0.000193. And I keep them with the zeros because I am using a cell phone calculator, and that's just easier to input for me. But it doesn't matter how you use them as long as they're right. And so that should equal 2.07 times 10 to the negative 4 for our equilibrium concentration of thiocyanate. So let's add that to the chart. And I've also done the rest, so we're going to add those. Now this box here looks like it's going to be a simple calculation and it's going to be really quick, but you actually have to calculate the Kc values 4 times and then get the average, because all it wants in here is the average. So we're going to do that down here below the other steps. So our calculated Kc values. Again, Kc is, or the equilibrium constant, is equal to the concentration of products, and at equilibrium, divided by the concentration of reactants at equilibrium. So for our equation, that looks like your product, the iron thiocyanate, divided by the concentration of iron 3 in this case, multiplied by the concentration of thiocyanate. So for trial 1, Kc would be equal to the concentration of our product, and that's from the table that we just did all those calculations for. Let's write equilibrium here so we know which concentration to use. Divided by the concentration of our product, our reactants multiplied together. And this is where the number gets crazy. So That would equal for me 1,135, and it should be somewhere around 40-ish. But our math is still correct, so that's what we're going to go with. So for trial 2, we do the same. Put our concentration of our products. Multiplied by our concentration of reactants. Now this is still all at equilibrium. And that's 1,668. And then I did the same for trial 3, which equaled 1,778. And then trial 4 was equal to 2,413. So I'm just going to get the average of all of those. All 4 of them added together. Divided by 4, how many we had. So our average Kc value then was equal to 1,748. So I'm going to just go back up to the worksheet and add that in. And then we're done. Please let me know if you have any questions on any of these. Hopefully, this will help you with your quiz too.